Alright, this is video number 2 for January 5th, 6th, and potentially a 10th if you are in 3B or 4B. Front page, we talked about the new formulas. We verified those new formulas. In fact, if you want to write those down on a side sheet or something, we're going to continue using those, so it'd be nice to reference those. But now, this is what it might look like to solve these types of problems. What it might look like on an assessment or something like that. We want to find sine of pi over 12. Well, we don't know really where, the value of this because it doesn't fall on our unit circle. However, what we can do is use the formula. And I'm actually going to give you the two radian measures here. So what we talked about in class is that if you look at pi over 3 and subtract pi over 4, okay? Well, now let's look. If you were to do that, then we need a common denominator since you're adding fractions. So our denominator here would be 12. 12, that's your least common multiple. And to go from 3 to 12, you're multiplying by 4, so we have to multiply our numerator by 4. So this would be 4 pi over 12. Similar thing here, from 4 to 12, you're multiplying by 3. 3 pi over 12. And so by subtracting these, your denominator stays the same. 4 pi minus 3 pi would give you 1 pi, or just pi. And so now, this is why this is helpful. We have pi over 12. We just showed that pi over 3 minus pi over 4 equals pi over 12. We also can see that if you have a unit circle, which is also something you're going to need, these two radian measures fall directly on your unit circle, which is helpful. And so what we can say is this is sine of pi over 3 minus pi over 4, since we showed that this equals pi over 12. And now we can use the formula. So we're using that sine formula, and it's minus. So what it's going to be is sine of pi over 3 times cosine of pi over 4, because this is your alpha, this is your beta. Now, in the original formula, minus is on the bottom of the plus minus. In the formula, it's plus minus here, so minus is on the bottom. Here in the sine formula, it's also plus minus. So since minus is on the bottom here, we also use the minus here since that's on the bottom. So this would be minus cosine of pi over 3 sine of pi over 4. So now we can simplify this. We know what all of these values equal. We can plug those in, simplify as far as we can. So if you look on the unit circle, sine at pi over 3 is square root of 3 over 2. If you want to pause, make sure you understand what's happening here. That might be good. I'm going to keep going just for time's sake. Cosine of pi over 4 would be square root of 2 over 2 minus cosine of pi over 3 would be 1/2 sine of pi over 4 square root of 2 over 2. Excuse me. Now what we need to do is simplify. So we're multiplying fractions here. Multiply straight across. Square root of 3 times square root of 2. I'm going to do this on the side. Square root of 3 times square root of 2. If we have the same root, there's a property that says we can keep that root and multiply what's underneath the root. So we have a square root, so the root stays. 3 times 2 is 6. So this would be square root of 6. 2 times 2 is 4. Minus 1 times square root of 2 is square root of 2. 2 times 2 is 4. Now, here we have to be careful. We got to be careful because although square root of 3 times square root of 2 is 6, square root of 6 minus square root of 2 does not equal square root of 4. So although you can multiply under the root, we cannot do this and combine like this. So what happens is your denominator stays the same, and then we subtract our numerators, and so we leave it like this. Okay. So ultimately what's happening here is we're just plugging in values. Make sure that you use the formula correctly. Simplify as far as we can. This is our exact value for this expression. All right. Okay, let's go to this one. Similar thing, right? We know that pi over 12 equals pi over 3 minus pi over 4. So we can do, I'm going to make a line here. Similar thing that we did here. We can say this is cosine of pi over 3 minus pi over 4. Now in doing that, what we say, we need to be careful with the cosine. Here, it was plus minus plus minus. For the cosine formula, again, I would highly recommend having this on the side so you can see what's happening here. It's plus minus, well, let me write it above it. It's plus minus inside the parentheses, okay? It's plus minus here, and so when we fill out the formula, this would be cosine pi over 3, cosine pi over 4. I'm just following the formula on the front side of the notes. But here, on this side, instead of it being plus minus, it's plus minus, and here, it's a little different, it's minus plus. So that's key. Minus is on bottom in this part here, so we stay with the on bottom here. Positive, plus is on bottom here. So this would be plus instead of minus. That's a key thing that we need to be careful with here. Key thing. And then we continue filling out the formula. Sine pi over 3 cosine at pi over 4. Okay. So again, be careful, especially with cosine. It can you can get lost there if you're not careful with the formula. A lot of people that's the biggest mistake I'm seeing. Now we can continue simplifying. Similar thing that we did up here. Cosine at pi over 3 would be 1/2. Cosine at pi over 4 would be square root of 2 over 2 plus sine at pi over 3 square root of 3 over 2, and cosine at pi over 4 square root of 2 over 2. Multiply, simplify. 1 times square root of 2 is square root of 2. 2 times 2 would be 4. Square root of 3 times square root of 2, we just showed is square root of 6. And so we end up with that as our value. So again, just be careful the way you read the formula. That's a key piece. Another key piece is figuring out the radian measures that add or subtract to give you what's here. Okay. Pause it, make sure you understand what's happening, reading the formula, using it, all of those great things. If you have questions, please let me know. Now, this last problem, I'm not gonna go through entirely. But I'm not, I would prefer for you to figure out 2 radian measures that add or subtract to give you 5 pi over 12, similar to what we did here. Now, I'm going to give you a couple options here. First, one option, if you're like, man, I'm stuck. If you're not, go ahead and solve it. I'm going to post a solution here in a second. Go ahead, try to solve it, do what you can. If you're stuck and like, man, how do you do that? One thing you could do is convert. So we can convert this to degrees by multiplying by 180 over pi. Okay. Then you could get something in degrees, a whole number, and it's a lot easier to figure out what adds subtracts to get you that value. Another thing you can do is here. We know we want 5 pi over 12. Well, maybe you do something like 12, right? And now you're trying to figure out what 2 numbers, if I add them in the numerator, would get me to 5. Now you need to be careful here, because if you choose like 4 pi and pi. 4 pi plus pi is 5 pi. However, if you do this, 4 pi over 12 simplifies to pi over 3. This doesn't simplify. This is not on our unit circle. So maybe these radians wouldn't be beneficial. Maybe try 2 and 3 and then simplify. That might be beneficial. Try it out. Either convert, go to degrees, or split the 5 up, 3 and 2, 1 and 4, see what happens, simplify those fractions, and then see what's on your unit circle. What you should end up with, your solution, I'm going to let you work it out. If you have questions, email me, please let me know. You should end up with this, which is the same as this. Either one of these are valid solutions. Again, try this one on your own. If you have questions, please let me know. Email, in class, whatever you need to do. Hopefully this is helpful. There is one more video. We'll do that. I'm going to do that, post that. That'll be the end of today's lesson.